In our third example problem, we're doing the reverse of the first problem. So we're looking at the consequence of that mutation, and then we're trying to diagnose it. So in this example, we're saying that our number 4 position is now complemented to a cytosine. So what happened? What was our mutation? From what to what? What kind of mutation was it? What changed? So I'm just going to look at that. My number 4 position, 1, 2, 3, 4, is a thymine. And thymine should be paired with adenine. But this problem tells me that it is actually paired to a cytosine. So what could have happened to make that happen? Well, that means that the thymine was behaving as though it was a guanine. So a thymine is a pyrimidine, and it's behaving as though it's a guanine, which is a purine. So that means I have a transversion. And my transversion is from a T to a G. So for these problems in particular, we want to know what happened to the original DNA to give us the new mutation. And in our last example problem, we're going to work with ultraviolet radiation, and we're going to assume that there is no translesion polymerase, and we're going to assume that every set of adjacent pyrimidines is going to lead to a deletion. So we want to know, after those deletions happen, how long is the new sequence going to be? So the first thing that I want to do is just scan my whole thing and find all of the adjacent pyrimidines. So all the adjacent cytosines and or thymines. So here I have a cytosine, thymine, and thymine and cytosine. So that means that these are all going to form those dimers that we talked about due to ultraviolet radiation. And so after this is replicated, right, those are all going to be deleted. So our new piece of DNA is going to be 1, 2, 3, 4, 5, 6 base pairs long.